the graphs of y equals f of x, which is the red one, and its image, which is the blue one, after a vertical and or horizontal compression are shown. We want to write the equation in terms of the function f. So again, that in terms of means on your equation, the right-hand side is going to have the function f. Now this is one, it's sort of working backwards. Up till now, we've always had the equation and drawn the graph. Now we have the graph and have to work backwards to get the equation. Okay? I'm going to say, well, let's look what's happened. Would you agree that they tell us that 3, 9 is on our original graph? We've got 2, -8 on our original graph, and 0, 0 on our original graph. Those are the 3 points that are given. And then we can see that something's happened, and it's changed, and now we've got 1.5, 4.5. And 2, 8 went to 1, -4. And 0, 0 stayed the same. So what I'm trying to do here is say, well, what is the technique that we did when we worked forward? And now that we work backwards, well, I've already got the answer, right? Normally when I was working forwards, I wrote something up here that said what happened. Can you see what happened? How is it that 3 could go to 1.5 and 2 could go to 1? Okay, you're doing 2 steps at once. What would I have written up here, though? X got multiplied by half, right? Yeah, like, and again, you're right, but you're skipping a step. So we'll try to do it as, you know, I would write up here that, oh, I need my x value to get multiplied by a half. And what happened to my y values? Okay, -8 to 4, 9 to 4.5. Can you see that they got multiplied by a half as well? So I'm going to write up here that my y values also got multiplied by a half. So I'm working backwards with the same technique that I used working forwards, undoing 1 step at a time. Sometimes if you try to undo too many steps at a time, you're going to get either lost or you're going to make a mistake in there. Now that I have this, I can write the equation in terms of f for the blue one. The y by a half, that's a vertical compression. That's going to be outside of my function, right? Anything that happens to y is outside of my function. And anything that happens to y is exactly as you see it. So there's going to be a 1/2 outside of my function f. And so we need this in function notation, so there's going to be an f on the right-hand side. Now, inside my function, that's whatever affects x. My x value is getting multiplied by a half. So what would have had to have been inside the function to do that? 2. Later on, we're going to have our stretches, compressions mixed together with translations and the adding and subtracting stuff all together. And it won't be easy just to do it backwards like this. We're going to have to develop a little bit more of a strategy. So I'm going to introduce that strategy to you now. If you just have vertical and horizontal compressions, I suggest doing the points because it's quite easy to see what happens. Okay? But another way to analyze this is just add some space here. And this is what we're going to look at later, is we're going to think about 2 points on our original graph. So I'm going to call this point A and this point B. And on my image graph, and often we label points on our image graph with a little dash, or in mathematics we would say a prime symbol, A prime and B prime. And what we're going to do is we're going to figure out these 1/2 and 2 values, or figure out what x is multiplied by looking at horizontal and vertical distances between points. So here, starting off with horizontal, from A to B. That was on our original graph. Maybe I'll change that even to red. Can you see that if you go from A to B, it's 1 unit? Because you go from 2 to 3. That would be the horizontal distance between A and B. If you look at the horizontal distance between A prime to B prime, you go from 1 to 1.5. How do you go from 1 to 0.5? You would have to multiply x by 1/2. The horizontal distance was 1, now it's 1/2. How would I do that? I would have to multiply x by 1/2. Okay? Vertical, we do the same thing with our vertical distances. We look at A to B on the red graph. A starts at -8 and goes all the way up to 9. Can you see that you've gone up 8 plus 9, 17 units? And if you look at A prime, which is at -4, up to B prime, which is 4.5, that goes up 8.5. Again, how would we change 17 to 8.5? You would have to multiply y by 1/2. So this technique at looking at 2 points, their original horizontal distance and their new horizontal distance, 2 points, their original vertical distance and their new vertical distance, will also tell you what you'd have to multiply x and y by. Okay? You'll need this technique later when we add translations where we add and subtract, move left and right. But for now, this technique is not as easy as just the points, right? Could you see it directly by just doing the points? Absolutely. So if you just have stretches and compressions, that would work fine. Okay, questions for this one are 12, 13, and 14. I'll give you some time in period 3 for this.